Hi students, let us solve this problem about the continuity equation. So in this problem we have a garden hose of inner radius 1 centimeter that carries water at 2.0 meters per second. The nozzle at the end has a radius of 0.20 centimeters. So the question is, how fast does the water move through the nozzle? What is an ideal fluid? This equation, the continuity equation, is going to apply for an ideal fluid. An ideal fluid is a fluid that is incompressible, that undergoes laminar flow, and that has no viscosity. So basically in the problem, they give us this pipe, right? Or garden hose, right? And then we have this area 1 here, that is the area corresponding with the section of 0.20, of 1.0 centimeters of radius. And of course, the fluid passing through this region have a velocity 1. We call this area area 1. And then we have this other section, that is the section corresponding with the radius of 0.20 centimeters, and the area corresponding to that section is called area 2. And the fluid at that section is going to have a velocity that we call velocity 2. So basically the continuity equation says that the flow rates to different points are equal. So the flow rate, that is basically the product of the area times the velocity of the fluid in this section, is equal to the flow rate in this other section. So the continuity equation basically says that the area 1 times the velocity 1 should be equal to the area 2 times the velocity in the region 2. We're going to then now solve the problem. So what we know that the radius of the area 1 is a radius of 1.0 centimeters. We know that the radius of the region 2 is a radius of 0.2 centimeters. So I know that the area of the circle is pi times r squared, pi times the square of the radius. So I say that pi times 1.0 centimeters square times 2.0 meters per second is equal to the area in the second region. You know that is pi times 0.20 centimeters squared times the velocity 2. So just to be very clear, this here is the area 1, pi times the square of the radius 1. This part over here is the area 2, that is pi times the square of the radius 2. And of course, this one here is the velocity 1. So we must now find the velocity 2, so we're going to be solving for B2. So we can say that B2 is equal to pi times 1.0 centimeters squared times 2.0 meters per second divided by pi times 0.20 centimeters squared. You cancel pi out. So you will square 1, so it's going to be 1 centimeter squared times 2.0 meters per second, and then you're going to divide that by 0.2 squared, that is going to be 0.04 centimeters squared, and the result of that is going to be 50 meters per second. So we found, that the velocity 2, that means the velocity in this region with less radius, is of course higher than the velocity of the fluid in this other region, and is equal to 50 meters per second in this case. So this is basically what the continuity equation is about. It's a very important equation of fluid, right? And we're going to be solving, a lot of problems involving this continuity equation. Thank you.